just
Okay. Then these are positive and negative, like we said. We'll fix it and we're here. Then we have our resistor. Our resistor moves from the collector
are you saying it now?
of the transistor to the positive of the diode we are using. It's from here. So here.
Things have done small now.
Okay. And then use our jumper wire. Now we are connecting this place is our emitter, so we connect one jumper wire to where our emitter is connected. So put it at the back here. And we put another one at the negative of the light emitted bulb here.
No, I just fire.
And the last one, which will be our sensor, will be at the base of your transistor, which is here. So now let's try to check if this will work. So we cover the battery to battery cap. And now here is our negative and these are positive. So the red goes to their positive. And the black go to our negative.
So we're expecting to see the light pop up right now, but it's not coming on. What's happening? Because the base is not yet triggered. There is a loophole in this transistor. So the moment I connect this base with a charge, now let's see how it works. It works this way. The emitter wants to send current to the collector, but then the base is like a switch. It has to be triggered for it to allow current to pass through the emitter, from the emitter to the collector. So how do I incite? How do I charge this base? I have to introduce a charge to it. And now since this is NPN, it means I'm going to be introducing a positive charge to this base so that the base can be triggered to now allow current to flow through the collector to the LED. So now once I hold this base, I'm expected to hold this positive terminal and then the light comes up. Let's see it. You see it? It comes on. Now what if I hold the negative side and
There are
the
lots of
base? Let's see what
VPNs out
happens.
there at all different price points. Many of them are even free.
See, it's not coming
So,
on.
should you use
Why?
a free VPN?
This is NEN.
This video will
The
break
P
down the
is the base.
advantages and the
It's telling you that it needs
free
a positive
VPN
charge
to
to
help
trigger
you
it
make
up.
informed decisions.
So
But first,
only positive
let's
charge
talk
triggers it.
about how all VPNs work. Both
So this is
When you connect to a
working.
VPN, you get a
now.
different IP
What happens
address
if we
that is
connect
shared by many other
it directly
people,
instead
which
of using our
masks your
hands?
real
Let's
identity
see.
and location. Besides the privacy
You see, it's not
benefits,
lighting
this
up.
can also allow you to access
connected
sites and
directly, but it's not
services
lighting
that
up.
may be
What
restricted where you are.
Now,
Your traffic
this
goes
transistor
through an encrypted
just need a
tunnel
very
that
little
should,
amount.
in
The
theory,
base need a
keep it
little
secure
amount
and
of
private.
charge.
If your
Just a
goal of
little
using
amount
a
of
VPN is just to temporarily change your IP address and privacy isn't really a concern, then a free VPN may be useful. You might be able to, for example, read articles on blocked websites or watch videos that aren't available in your region. A free VPN is likely to be slower than a paid one, and it will almost always offer fewer choices of location. It's also more likely to suffer outages or simply not work on the site you're trying to use. If you find one that works for your situation, you might be okay. But it might not be the safest idea to use a free VPN for the long term, or for anything more important.
After all, running any VPN service costs money. If a provider doesn't charge you a subscription fee, then it must be recouping those costs somewhere else. Some may offer a paid tier, while offering a much more limited service for free. The difference between the free and paid versions is likely to be substantial, but if you're not expecting much, it could work. Others may simply cut corners, offering weak or non-existent encryption, or engaging in poor security practices that put your traffic or your personal data at risk. And finally, some may even be abusing their access in order to log and record your browsing and shopping habits for your experience and security. Invites and publicize it.
Using components, electronics components to establish, to maintain, to control the activity, switching on, off, fast, slow, low activities in. And in this era we are that is need for development of activities in electronics, your automation system, your control system, robots control, motor control, movement of most virtually all electronics components make use of switches, which switch between some terminals or connections, which are done to majorly we have 0 and 1 in most of our logic controls, which in many of the microcontrollers we still have the output 0 and 1. Now the key components that is required, switch, as I've said earlier, is just to open and close circuit. And in electronics switching, majorly we have the transistors, the relay, we have the diode, we have the control signals, input signals that determine the states of source and the load you want to carry. This aspect of switching, load, is one of the major things, attributes we must first consider. The load you are carrying will determine the type of electronic switching that you adopt and the purpose of the switching. Maybe you are switching using voltage control. And because of this class, we will dwell more about. Now, what are the fundamental switching mechanism? We have different types of switching mechanism. If we talk about different types of relay, those are mechanical switching, physical movement of switch. Once its relay is powered, it moves from normally close to normally, close from normally open, vice versa. It all depends on the power. Normally close will be active, and once you switch it on, it goes to normally.
Like the link you sent to me now.
So it all depends on what you want to use it. Using understanding of switching will make it easy to develop electronics circuits or boards that you can use to adapt into your daily activities or development. We have solid state switching. These parts involve no movement. We have the use of transistors, MOSFETs, any related FETs. We have solid state relay also, which all this works with the principle of no movement. We will not see a physical movement, not like the mechanical switching. Those most mechanical switching, we still attribute them as electronic switching because it also requires electronic.
Alright, transistor is actually a very important electronic component that is usually used in building electronic circuits.
These things are also switches.
My name is Honorable and I'm here with Sarah. Today we are going to be discussing the concepts in electronics, and there's this basic component in electronics that we'll be discussing today, and it's a transistor. So we're going to be seeing what a transistor is, and the types of transistors available, and also the uses of transistor, the application of transistor. And at the end of this video, we are going to be making a very simple electronic switching circuit to see how we can actually implement these transistors in our everyday life or in an electronics world. Okay, so just keep in touch, stay tuned with us as we ride on this journey. Thank you.
Okay. A transistor is a semiconductor device, usually silicon. It's used to amplify or switch an electric signal or power.
Alright guys, the transistor is a very crucial element used in building electronic circuits. It's very, very fundamental in building electronic components. Basically, we have some basic components in electronic circuits that you will find in every electronic build up, every electronic circuit, in which transistor is part of them. And the transistor is made up of is of two kinds. We have the BJT and the FET.
Now we have types of transistors. We have the bipolar, which is the BJT transistor, and we have the field effect transistor effect. Now the bipolar transistors have two kinds, the NPN and the PNP. The NPN is negative layer, while the PNP is the positive layer.
For the FET, it's just a field. The FET is field effect transistor, and it has two kinds as well. So it has the JFET, which is the junction field effect transistor, and MOSFET, metal oxide semiconductor field effect transistor. These are awesome elements that we can find in electronic circuits because they usually help us to amplify our signals, and also they can act as switching. And that's why we refer to them as electronic switching, right? So now, for you to know the actual transistor you are working with, you have to check the value. Where there's a part number written on the transistor that you can actually browse through on Google. You just write the number there and you write data sheet on it, and then you send it, and they will give you the details, the data sheet of that transistor.
Now, examples of NPN, we have the 2N222, we have the 3904 as the NPN, therefore PNP, we have the 3906 and others.
Let me just show you a transistor, how it looks like. Okay. It's a very small component. You might see it and you just throw it away, you rub it off. So this is a transistor. See how very, very small it is, right? This is a transistor, and what I'm holding here right now is a BJT transistor, and you can look at it very closely. It has three terminals. Let me bring the terminals for you. See, it has three terminals.
We have the emitter, the base, and the collector.
So most of the transistor we've seen so far, like the ones we've been using so far, the base is usually situated at the middle. But maybe for some kind of transistor, it might differ. For you to know the actual transistor you are working with, you have to check the value. There's a part number written on the transistor that you can actually browse through on Google. You just write the number there and you write data sheet on it, and then you send it, and they will give you the details, the data sheet of that transistor.
That means we're building an electronic switch circuit.
The apparatus we'll be needing for this experiment is the breadboard. This is a breadboard, and then we'll be needing is a battery connector. Okay, so this is our battery, and it's a 9-volt battery. Now this is our resistor. It's a resistor. This is how it looks like. And we need our LED, a light emitting diode, the LED, and then our transistor, the super transistor that acts as the switch. Okay, we have our jumper wires for connection for connections. So let's start building.
Our resistor has no polarity. You can use anywhere positive or negative. Then here we have two legs here. This is the shorter leg and the longer leg. The longer leg is our positive and the shorter one is our negative. So this is our output and this is our anode. We check what type of transistor is using. Let's check the number. I have S9014. This is NPN. This is an NPN. transistor. So now you put it to like, so this will be our emitter, our base and collector. So this bubble, they are all connected. So let's try to put it here.
And the drain, as we have the emitter and collector, so they work in that principle. During the practical class, we show you this
Then
and how to
these are positive and negative, like we said.
your
So
multimeter
fix it somewhere here.
of data sheet.
Then we have our resistor.
What are the key difference
Our resistor moves from the collector
between
of the transistor to the positive of the diode we are using.
If you can look at it now,
From there,
control mechanism.
So,
one is controlled.
here.
One controls voltage and one the effects controls current. Power consumption, power consumption are not the same.
Okay.
Noise characteristics.
Use our jumper wire. Now we are
We
connecting.
have a lot of MOSFETs that
This place is our emitter, so we connect one jumper wire to where our emitter is connected. So put it at the back here.
get some MOSFETs. MOSFET that have effects
I
products
will
that
put
are very
another one
sensitive to
at the negative of the light emitted bulb
impedance, also
here.
vary temperature and circuit applications.
And the last
There
one,
are some
which will be our
applications that
sensor,
you cannot
will be at the base of your
the
transistor.
device that you are controlling
Is here.
is different from
So
a
now
device
let's try to
where
check
you are
if this
controlling,
will work. So you cover the battery to
those are the
battery up.
key difference. We show you some of these
And now,
in the
here is our negative and these are positive. So the red go to their
Now,
positive.
what are the advantage of using electronic switching? They are fast in switching. Their switching speed is very high.
And the black
For
go
example, you
to
design
our negative.
electronic switching to do changing over.
So we're expecting to see the light pop up right now, but it's not coming on. What's happening? Because the base is not yet triggered. There is a loophole in this transistor. So the moment I connect this base with a charge, I will, now let's see how it works. It works this way. The emitter wants to send current to the collector, but then the base is like a switch. It has to be triggered for it to allow current to pass through the emitter, from the emitter to the collector. So how do I how do I charge this base? I have to introduce a charge to it. And now since this is NPN, it means I'm going to be introducing a positive charge to this base so that the base can be triggered to now allow current to flow through the collector to the LED. So now once I hold this base, I'm expected to hold this positive terminal and then the light comes up. Let's see it. See it. It comes on. Now what if I hold the negative side and the base? Let's see what happens. See, it's not coming on. Why? This is NPN. The P is the base. It's telling you that it needs a positive charge to trigger it on. So only positive charge triggers it on. So this is it. It's working. Now what happens if we connect it directly instead of using our hands? Let's see.
And what is this stream? What am I streaming now?
You see, it's not lighting on. It's connected directly, but it's not lighting on. What happens? Now, this transistor just needs a very little amount. The base needs a little amount of charge, just a little amount of charge to trigger it. So you don't really need to put direct 9 volts to it. You just need a very little amount of charge to trigger it. So since I'm holding it, I'm acting as a resistance to it. So I'm actually reducing the amount of current that is going to the base, and that's the reason why when I hold it, it powers on. But when I connect it together, it's not power on because it is. And secondly, the transistor has a capacity of current or voltage it can take through the base. Now, if I don't want to hold it, it with my hands, I can actually introduce a resistor to it and then see what happens. When I put a resistor in between, see what happens. It works. So the idea is that I'm reducing current that is going into the base trigger. So in real life situation, you can use this to make a touch sensor such that you can just hold some two LED metal like this and see the light perfect. So this is just a little circuit you can use a transistor to build. There are many more applications of transistor. The idea is that I'm reducing classical is just used for the switching to show how to in real life situation. While I hold these two together, the base is such that and then current flows from the emitter to LED metal like this and collector to the right most of the load. So this is just a circuit you can use a transistor to build. The idea is reducing classical experiment on how to switch LED to show how to in real life situation. While I say I like to and then current flows from the emitter to LED metal like this and collector. So this is just a
That's what I'm observing.
Alright guys, it's very, very fundamental. Companies basically have some basic components that you find in every electronic circuit. In which transistor is part of them, and the transistor is it's of two kinds. We have the BJT and the FET.
Now we have types of transistors. We have the bipolar, which is the BJT transistor, and we have the field effect transistors. Now the bipolar transistors have two kinds, the NPN and the PNP. The NPN is negative, positive, layer, while the PNP is transition negative bipolar layer to the BJT transistor, and we have the field effect transistor and it has two kinds. Now the bipolar transistor has two kinds, the NPN and the PNP. The NPN is negative,
and they will give you the detailed implications of that transistor.
Now, examples of NPNs, we have the 2N222, we have the 3904 as the NPN, therefore PNP, we have the 3906 and others.
Let me just show you a transistor, how it looks like. Okay? It's a very small component, you might see it and you just throw it away, you rub it off. So this is a transistor.
Class is
See how very, very small it is, right? This is a transistor. And what I'm holding here right now is a BJT transistor. And you can look at it very closely. It has 3 terminals. Let me bring the terminals for you, see? It has 3 terminals. 3 terminals.
They have the emitter, the and collector.
So most of the transistors we've seen so far, like the ones we've used so far, the base is usually situated at the middle. But maybe for some kind of transistor it might differ. For you to know the actual transistor you are working with, you have to check the value. There's a part number written on the transistor that you can actually browse through on Google. You just write the number there and you write data sheet on it, and then you send it, and they will give you the details, the data sheet of that transistor.
That means we're building an electronic switch, I think.
The apparatus we'll be needing for this experiment is the breadboard. This is our breadboard, and then we'll be needing is a battery connector. Okay, so this our battery, and it's a 9-volt battery. Now this is our resistor. It's a resistor. This is how it looks like. And we need our LED, light emitting diode, the LED, and then our transistor, super transistor that acts as the switch. Okay, we have our jumper wires for connection to the connections. So let's start building.
Our resistor has low polarity, so you can use anywhere positive. Then here we have 2 legs here. This is the shorter leg and the longer leg. The longer leg is our positive and the shorter one is our negative. So this is our output and this is our anode. We check what type of resistor we're using. Let's check the number. We have S9014. This is NPN. This is an NPN transistor. So now you put the 2 legs. So this should be our base and collector. So this problem, they are all connected. So let's try to fix it here. This is an NPN transistor. So now so this should be our okay. Then we are positive and negative, like we said. So fix it and we're here. Then we have our resistor. Our resistor moves from the collector of the transistor to the positive of the diode we are using. Like we said, from here. So yes, then we have our resistor. Our resistor moves from the collector of the transistor to the positive. Okay, and then use our jumper wire. Now we are connecting. This place is our emitter, so we connect one jumper wire to where our emitter is connected. So we put it at the back here. I will put another one at the negative of the light emitted bulb here. This place is our emitter, so we connect one jumper wire. And the last one, which will be our sensor, will be at the base of your transistor. Here. So now let's try to check if this can work. So we're covering the battery to that. And now here is our negative and this is our positive. So the red plate is our positive. So now let's try to check if this can work. And the black go to our negative. And now here is our negative.
So we're expecting to see the light pop up right now, but it's not coming on. What's happening? Because the base is not yet triggered. There is a loophole in this transistor. So the moment I connect this base, with a charge, now let's see how it works. It works this way. The emitter wants to send current to the collector, but then the base is like a switch. It has to be triggered for it to allow current to pass through the emitter, from the emitter to the collector. So how do I how do I charge this base? I have to introduce a charge to it. And now since this is NPN, it means I'm going to be introducing a positive charge to this base so that the base can be triggered, now allow current to flow through the collector to the LED. So now once I hold this base, I'm expected to hold this positive terminal and then the light comes up. Let's see it. You see it? It comes on. So that the base can be triggered and allow current to flow through the collector. Now what if I hold the negative side and the base? Let's see what happens. See, it's not coming on. Why? This is NPN. The P is the base. It's telling you that it needs a positive charge to trigger it on. So only positive charge triggers it on. So this is it's working. Now what happens if we connect it directly instead of using our hands? Let's see. It's telling you that see, it's not lighting on. So it's connected directly, but it's not lighting on. What happens? Now, this transistor just needs a very little amount. The base needs a little amount of charge, just a little amount of charge to trigger it. So you don't really need to put direct 9 volts to it. You just need a very little amount of charge to trigger it. So since I'm holding it, I'm acting as a resistor or a resistance to it. So I'm actually reducing the amount of current that is going to the base, and that's the reason why when I hold it, it powers on. But when I connect it together, it's not power on because and secondly, the transistor has a capacity of current or voltage it can take through the base. Now, if I don't want to hold it with my hands, I can actually introduce a resistor to it and then see what happens. When I put a resistor in between, see what happens. See, it works. So the idea is that I'm reducing current that is going into the base trigger. So in real life situation, you can use this to make a touch sensor such that you can just hold some two legs metal like this and see the light pops up. So this is just a little cycle.
This is a transistor. It's one of the most important devices ever to be invented.
But for this,
so we're going to learn
practical
how they work in detail in this
to show
video.
how switching works. So while I hold these two together,
Transistors
the base
come
is
in many
triggered
shapes
and then
and
current
sizes.
flows from
There are
the
two main
emitter
types, the
into the
bipolar
collector
and the field
to get
effect.
the load.
We're going to mostly
so
focus
I'll
on
do
the
it.
bipolar version in this video.
Lance,
Transistors
this little
are small
experiment, a
electronic components
very
with
little
two main functions.
basic experiment
Act
on
as a
how
switch
switching electronic switch works.
circuits,
Okay,
and
so
they can also
see now
amplify
next
signals.
tutorial.
Small, low-power transistors are enclosed in a resin case
Alright,
to help protect the internal
transistor is
part.
actually very
But higher power transistors will have a carbon metal
electronic
case,
company
which is
that is usually used in building electronic
this will damage the
circuits.
components over time. We usually find these metal body transistors attached to a heatsink, which helps remove the unwanted heat. For example, inside this DC bench power supply, we have some MOSFET transistors which are attached to very large heatsink.
And there's this basic
Without the heatsink, the
electronics that we're
components
discussing
quickly
today,
reach
and it's
45 degrees
the
Celsius
transistor.
or
So we're going to be
113
seeing what a
degrees
transistor
Fahrenheit.
is
With a current
and
of just 1.2
the types of transistors
They
available
will become
and
much
also
hotter
the uses of the transistor, the application of transistor, and at
But
the end of
for
this
electronic circuits with small
video,
currents,
we are
can
going to
just
be making
use
a very
body
simple
transistors which do
electronic
not
switching
require a
circuit to see
heatsink.
how we can.
On the body of the transistor, we find some text. This will tell us the part number, which we can use to find the manufacturer's data sheet. Each transistor is rated to handle a certain voltage and current, so it's important to check these sheets. Now, with a transistor, we have 3 pins, labeled E, B, and C. This stands for the emitter, the base, and the collector. Typically, Typically, with these resin body type transistors with the flat edge, the left pin is the emitter, the middle is the base, and the right side is the collector. However, not all transistors use this configuration, so do check the manufacturer's datasheet. We know that if we connect a light bulb to a battery, it will illuminate. We can install a switch into the circuit and control the light by interrupting the power supply. But this requires a human to manually control the switch. So how can we automate this? For that, we use a transistor. This transistor is blocking the flow of current, so the light is off. But if we provide a small voltage to the base pin in the middle, it causes the transistor to start allowing current to flow in the main circuit. So the light turns on. We can then place a switch on a controlling pin to operate it remotely, or we can place a sensor on this to automate the control. Typically, we need to apply at least 0.6 to 0.7 volts to the base pin for the transistor to turn on. For example, this simple transistor circuit has a red LED and a 9-volt power supply across the main circuit. The base pin is connected to the DC bench power supply. The circuit diagram looks like this. When the supply voltage to the base pin is 0.5 volts, the transistor is off, so the LED is also off. At 0.6 volts, the transistor is on, but not fully. The LED is dim because the transistor is not yet letting the full current flow through the main circuit. Then, at 0.7 volts, the LED is brighter because the transistor is letting almost a full current through. And at 0.8 volts, the LED is at full brightness. The transistor is fully open. So what's happening is we're using a small voltage and current to control a larger voltage and current. We saw that a small change to the voltage on the base pin causes a large change on the main circuit. Therefore, if we input a signal to the base pin, the transistor acts as an amplifier. We could connect a microphone which varies the voltage signal on the base pin, and this will amplify a speaker in the main circuit to form a very basic amplifier. Typically, there is a very small current on the base pin, perhaps just 1 milliamps or even less. The collector has a much higher current, for example 100 milliamps. The ratio between these two is known as the current gain and uses the symbol beta. We can find the ratio in the manufacturer's datasheet. In this example, the collector current is 100 milliamps and the base current is 1 milliamp. So the ratio is 100 divided by 1, which gives us 100. We can also rearrange this formula to find the currents also. We have two main types of bipolar transistors, the NPN and the PNP type. The two transistors look nearly identical, so we need to check the part number to tell which is which. With an NPN transistor, we have the main circuit and the control circuit. Both are connected to the positive of the battery. The main circuit is off until we press the switch on the control circuit. We can see the current is flowing through both wires to the transistor. We can remove the main circuit, and the control circuit LED will still turn on when the switch is pressed, so the current is returning to the battery through the transistor. In this simplified example, when the switch is pressed, there are 5 milliamps flowing into the base pin. There are 20 milliamps flowing into the collector pin, and 25 milliamps flowing out of the emitter. The current therefore combines in this transistor. With a PNP transistor, we again have the main circuit and the control circuit, but now the emitter is connected to the positive of the battery. The main circuit is off until we press the switch on the control circuit. We can see with this type that some of the current flows out of the base pin and returns to the battery. The rest of the current flows through the transistor and through the main LED and then back to the battery. If we remove the main circuit, the control circuit LED will still turn on. In this example, when the switch is pressed, there are 25 milliamps flowing into the emitter, 20 milliamps flowing out of the collector, and 5 milliamps flowing flowing out of the base. The current therefore divides in this transistor. I've placed these side by side so you can see how they compare. Transistors are shown on electrical drawings with symbols like these. The arrow is placed on the emitter. The arrow points in the direction of conventional current so that we know how to connect them into our circuit. To understand how a transistor works, I want you to first imagine water flowing through a pipe. It flows freely through the pipe until we block it with a disc. Now, if we connect a smaller pipe into the main one and place a swing gate within this small pipe, we can move the disc using a pulley. The further the swing gate opens, the more water is allowed to flow in the main pipe. The swing gate is a little heavy, so a small amount of water won't be enough to open it. A certain amount of water is required to force the gate to open. The more water we have flowing in this small pipe, the further the valve opens and allows more and more water to flow in the main pipe. This is essentially how an NPN transistor works. You might already know that when we design electronic circuits, we are going to use conventional current. So in this NPN transistor circuit, we assume that the current is flowing from the battery positive into both the collector, base pin, and then out of the emitter pin. We always use this direction to design the circuit. However, that's not what's actually occurring. In reality, the electrons are flowing from the negative to the positive of the battery. This was proved by Joseph Thomson, who carried out some experiments to discover the electrons and also proved that they flow in the opposite direction. So, in reality, electrons flow from the negative into the emitter and then out of the collector to the base bin. We call this electron flow. I'll place these side by side so you can see the difference in the two theories. Remember, we always design circuits using conventional current method. But scientists and engineers know that electron flow is how it actually works. By the way, we have also covered how batteries work in detail in our previous video. Do check that out. Links will be found in the description down below. Okay, so we know that electricity is the flow of electrons through a wire. The copper wire is the conductor, the rubber is the insulator.
Now we have
The
types
electrons
of
can flow easily through the copper,
transistors. We have the
but they
bipolar,
can't flow through
which
the
is the
rubber or
BJT
insulator.
transistor,
If we look at
and
this
we have
basic
the
model of an atom
tuned
of a
effect
metal
transistor.
conductor, we have the nucleus of the
Now the
center.
bipolar
This is
transistor
surrounded
has
by a number of
two types,
orbital shells
the
which hold the
NPN
electron.
and NPN.
Each shell holds a
The
maximum number of
NPN
electrons,
is negative,
and an electron is
positive,
have a certain amount of
negative
energy
layer, while the
accepted
PNP
into
is
the shell.
negative,
The electrons
positive
located
layer.
furthest away from the nucleus hold the most energy. The outermost shell is known as the valence shell. A conductor has between 1 and 3 electrons in its valence shell. The electrons are held in place by the nucleus. But there is another shell known as the conduction band. If an electron can reach this, then it can break free from the atom and move to other atoms. With a metal atom, such as copper, the valence shell and the conduction band overlap, so it's very easy for the electrons to move. With an insulator, the outermost shell is packed. There's very little to no room for an electron to join. The nucleus has a tight grip on the electrons, and the conduction band is far away, so the electrons can't reach this to escape.
Now,
Therefore, electricity cannot flow through this material. However, there's another material known as a semiconductor.
we have the
Silicon is the type of a
3904
semiconductor.
as the
With this material, there's one too many electrons in the valence shell for it to be a
and
conductor.
others.
Let me just show you a transistor,
But
how
as
it
the
looks like.
conduction band is quite
Okay.
close, if we provide some external
It's a very
energy,
small component, you might see it and
electrons will
you just
gain
throw it
more
away and rub
energy
it off.
to make the jump
So this is a transistor.
into the conduction band and become
See how
free.
very, very small it
Therefore,
is,
this
right?
material
This is
can
a
act
transistor,
as an
and
insulator
what I'm holding here right now is a BJT
Your
transistor.
silicon has almost
And you can look at it very
no
closely. It
electrons.
has 3
So
terminals.
what
Let
engineers
me bring the
do
terminals for
is
you.
dope the silicon
It has
with a
3
small amount
terminals.
of another
3
material,
terminals.
which changes its electron electrical properties. We call this p-type and n-type doping. We combine these materials
Most
to form
of the transistors we've seen so far, like the ones we've
sandwich
used
these
so
together
far,
to form an
the base is usually situated at the middle.
Inside
The
the
name for some kind of transistor
has the
is an
collector pin
amplifier.
and the emitter
For you
pin.
to know the actual
Between these, in an
transistor you are working with, you have to check the value. So there's a part number written on the transistor that you can actually browse through on Google. You just write the number there and the data sheet mate, and then you send it, and they will give you the details, the data sheets of that transistor.
resin to protect the internal material. Let's imagine the silicon hasn't been doped yet, so it's just pure
Apparatus to be
silicon.
needing for this experiment
Silicon
is
atom is
the
surrounded
breadboard.
by 4 other silicon
This is a
atoms.
breadboard, and the middle exchange is a battery connector. They will give you the details. Okay, so this our battery, it's a 9-volt battery. Now this is our resistor. Apparatus is a resistor for this experiment, like the breadboard, and this we need our LED and the lights. Exchange the battery to LED. They will give you the and then our transistor, our super transistor, that acts as the switch. Now this is we have our jumper wires for connection and connections. So let's start with the lights.
Our emitter has no polarity, so you can use anywhere. Then here we have two legs here, shorter leg and a longer leg. The longer leg we are producing, and the shorter one we are able to take power out and we check what type of transistor we will let the number around F9L14. Then we will choose NPN, with an NPN and a transistor. So now we use this to be our emitter of the electrode. So since they are all connected, so let's try to picture. Then we have our resistor. Our resistor moves from the collector of the transistor to the positive of the
I just want to be safe as my career. What's everywhere right now? Cannot shout.
So how do I decide? how do I charge this? I have on the page the charge code. Now since this is N on the electron, it means I'm going to be introducing a positive charge in this place so that the base can be triggered. Now allow current to go through an collector to the so now once I hold this base, I'm expected to hold this and the positive charge and the light comes up less. Now what if I go to the negative side and do this? Let's see what happens. Now once I send it to so it's now coming up twice. This is energy of the base. It's telling you that it needs to positive charge to trigger it. So any positive charge triggers it. So this is
A higher voltage on the base pin fully opens the transistor.
now what happens
which
if
means
we connect
more
it directly
electrons
instead of
moving
using our
into
hands?
the
Let's see.
PSAT relay. Therefore, more electrons are pulled across the
See,
reverse
it's not
bias.
lighting on.
We also see
It's connected
more
directly, but it's
electrons
not lighting
flowing in the emitter
What
side
happens?
of the transistor
Now,
compared to the collector side.
This transistor just needs a
Okay,
very
that's it for
little
this
amount.
video.
The base
To
needs a
continue
little
learning
amount
about
of
electronics engineering,
charge.
click on one of the videos
Just a little
on
amount
screen
of
now,
charge
and
to
I'll catch you
trigger
there
it.
for the next lesson.
So you don't really need
Don't
to
forget
put
to follow us on
direct 9
Facebook,
volts to
Twitter,
it. It just
LinkedIn,
needs a very little
Instagram,
amount of
and
charge
of course
to
the
trigger it. So
engineeringmindset.com.
since I'm holding it, I'm acting as a resistor or a resistance to it. So I'm actually reducing the amount of current that is going to the base.
Hey
And
there
that's the
guys,
reason why
Paul
when
here
I
from
hold it, it powers on.
engineeringmindset.com. In this
But when
video,
I
we're
connect
going
it
to look at
together, it's
diodes
not
to
power
understand the
because
basics of how they
and
work,
secondly,
as
the
well as
transistor
where
has a
and why we
capacity
use
of
them. So what is a
current or
diode?
voltage it can
A
take
diode
through
looks something
the
like
base.
this, and it comes in
Now,
different
if I don't want
sizes.
to hold it
They
with my
typically
hands,
have a
I can
black
actually
cylindrical
introduce
body that has a
a
stripe at one
resistor
end, as well as some leads
to
coming
it,
out to allow
and
us to
then see what
connect it into a
happens.
circuit.
When I put
This
a
end is
resistor
known as the anode,
in
and this
between,
end is the cathode.
see what
And we're going to
happens.
see what that means later on in this video.
it works.
You can also get other forms such as
So
the
the
Zener
idea is
diode
that
or
I'm
an LED,
reducing
which
current
is a light
that is
emitting
going into the
diode. But we're
base
not going to cover
to
those
guide
in this video.
So in real life
A
situation, you
diode
can use
allows
this to
current
make
to flow
a
in
touch
only
sensor
one direction in a
such that you
circuit.
can just hold
If we
some
imagine a water pipe with a swing
two
valve
legs
installed,
like this
as
and
water flows
see
through
the
the
light
pipe,
pops up.
it will push
So
open the
this is just
spring
a
gate and
circuit you
continue
can
to
use
flow through.
a transistor
However,
to build.
if the water changes
There are many
direction,
more
the
applications
water
of
will push
transistor.
the gate
But
shut,
for this
and this will prevent it from flowing.
practical is just used
Therefore,
for
water
switching
can only flow
to show
in
how
one
switching
direction.
works. So
This is
while I
very
hold
similar
these
to a
two together,
diode. We
the
use it
base
to
is
control the
triggered
direction
and then
of current
current
in a
flows
circuit.
from the
Now, I've
emitter
animated this video using the
I believe
positive. However, you might be used to seeing
lamps,
conventional flow,
this
which
leads
is
to
traditional in
experiment in
electronics
very,
engineering,
very
and
little
this is where the electrons
basic
flow from the positive
experiments
to
on
the
how
negative.
switching electronic switching
Electron
works.
flow is what's actually occurring.
you see
You
now
might come
let's
across conventional
see
current
it,
still,
yeah.
as these explanations are easier to understand. Just be aware of the two and
Alright,
which one we're using. So
transistors
if we connect a diode into a simple LED circuit like this one, you see that the LED will only turn on when the diode is installed the
building
correct way.
electronic
And that's
circuits.
because it allows current to flow in only one direction. So depending on which way the diode is installed, this will act as either a conductor or an insulator. In order for the diode to act as a conductor, the stripe end is connected to the negative and the black end is connected to the positive. This allows current to flow. We call this the forward bias. If we flip the diode, it will act as an insulator and the current can't flow.
So
We
we're
call
going
this
to
the
see what the
reverse bias.
transistor is and
So how does the diode
types
work?
of transistors available.
As you may know,
and also
electricity is the
uses
flow
of
of free
transistor, the
electrons
application
between
of transistor,
atoms.
and at the end of
We
this
use copper wires because
video,
copper has a lot of
we
free
are
electrons,
making a
which makes it very
simple
easy to pass electricity
electronic
through.
switching circuit
We use
to see
rubber
how
to
we can
insulate the copper wires
actually
and keep us
implement
safe
these
because
transistors
rubber is an
in our
insulator, which
everyday
means its
life
electrons are held
electronics
very
world,
tightly
okay?
and they
So
can't
just keep
therefore
in touch,
move
stay tuned
between
with us
our
as
atoms.
we ride
If we
on
look at the
this
basic
journey.
model of an atom
Thank you.
for a metal
Okay.
conductor, we have the nucleus at the center, and this is surrounded by a number of orbital shells which hold the electrons. Each shell holds a maximum number of electrons, and an electron has to have a certain amount of energy to be accepted into each shell.
Alright guys,
The electrons
the
located
transistor is
farthest
a
away
very
from the
crucial
nucleus hold
element
the most energy.
used in building
The outermost shell is known as the valence
It's
shell,
very, very
and a
fundamental
conductor has
in
between 1
building
and
electronic
3 electrons in its
components.
valence shell.
Basically we
The
have
electrons are
some
held in place
basic
by the
components
nucleus,
in
but there's
electronic
another shell
circuits
known as the
that
conduction band.
we'll find in every
If an
electronic
electron can reach this, then it can break free from the atom and move to
in
another.
which transistor is part
With a
of
metal
it.
atom such
And
as
the transistor is made up
copper,
of,
the conduction band and the
it's of two
valence shell
kinds. We have
overlap,
the
so it's
BJT
very
and the
easy for the
FET.
electron to
Now
move.
we have types of
With an insulator, the
transistor.
outermost
We
shell
have the
is packed.
bipolar,
There's very little
which
to
is
no
the
room for an
BJT
electron to join.
transistor,
The nucleus
and we
has a
have
tight
the
grip on the electrons
field
and the
effect
conduction band is far
transistor
away,
effect.
so the electrons can't reach
Now
this
the
to escape.
bipolar transistors
Therefore,
have
electricity cannot flow through this material. However, there's another material known as a
the
semiconductor.
NPN
This is all the fine sir, my yesterday now that you scatter my details. I think you don't scatter my here yesterday. Huh? Looking for what you keep inside my drawer.